Pre-Calculus Chapter 2, Lesson 4, and in this video we want to take a look at synthetic division as a way of then confirming whether a linear factor or a linear expression is a factor of the polynomial. In the last video we looked at the remainder and factor theorem, so we're able to determine what the remainder is going to be before we do the division. Now we actually have to do the division. You remember from last year we did take a look at long division, and I'll just show you what we did last year. So if we wanted to divide 2x to the fourth plus x cubed minus 3 divided by x squared plus x plus 1, we'd set up our division problem. Notice here that we have placeholders for x squared and x. That's going to be very important, especially when we're doing synthetic division. Whatever exponent you start with, you must have an exponent or a placeholder for each exponent in descending order all the way down through the constant. We then divided the x squared into the x to the fourth, and then we multiplied, wrote this, and then added the opposite, etc., etc. We're not going to do that, and you remember that this actually, synthetic division becomes a shortcut for doing long division. So synthetic division is a shortcut for the long division. As I said, it's only for linear factors, so we can only do this when we have linear factors in the form x minus k, much like we were working with when we were doing remainder and factor theorems. We're going to use the zero of the divisor. In other words, we want to use the value that will make that linear expression zero. Now this is very important. We're going to use the zero of the divisor. There's two ways that this may be given to you, and you need to know that what you're doing in each case. So you want to use the zero. So if we want to know if x minus 4, or we want to use synthetic division with this linear factor, we want to use the zero. So we're going to use 4, or whatever makes this zero. If I'm told that the zero is 4, then I'm going to use the number 4, because again I'm using the zero. In this case I have to figure out what the zero is for myself. That's why I take the opposite, or I use what would make this zero. In this case I'm told what the zero is, so I simply use the number that they give me. So very important to make sure that you understand what you're doing here. You're using the zero, okay, and whether you have to figure it out for yourself or whether you're told what it is. The second thing is, remember that we have to use placeholders for every missing power, otherwise this won't come out very good for us. We're going to only use the coefficients, and then once we've done all the dividing, we'll put the variables back in at the end. Rather than going through a whole process of showing you and explaining every step, I'm just going to do a number of examples. I'd like you to watch the first two for sure, because in the second example there's a little twist to it that I need to make sure that you understand. But once you've watched those, just watch as many examples as you feel you need in order to make sure you have the concept in hand. For our first example here, we have 2x to the fourth minus 5x cubed plus 7x squared minus 3x plus 1 divided by x minus 3. So the first thing we do is we want to use the zero. So we need to know what makes this zero. That's the number 3. So that's the number that we're going to use in our dividing. And remember, we put that up in the left corner in a nice little box. We then list the coefficients across the top, making sure we have a placeholder for every power. So here I start with x to the fourth, so the coefficient's a 2. Then I have x cubed, its coefficient is -5. I have x squared. I have x to the first power, and then I have the constant. So 4, 3, 2, 1, 0. So I have a placeholder for every power from 4 on down, so I'm okay to go ahead and do my synthetic division. So I draw my line and I bring down the first value, and then I'm simply going to multiply and then add. 3 times 2 is 6. That goes under the next number, and then I add, so 6 minus 5 is 1. 3 times 1 is 3, goes under the next value. 7 and 3 is 10. 3 times 10 is 30, goes under the next value, and then I add. 3 times 27 is 81, and then add. So this last number ends up being my remainder. So this is not a factor of this polynomial because I do not get a remainder of 0, but I do have the answer of the division problem here. So now that we've done the division, we put the variables back in. You remember we start with a power 1 less than we began with. So because this was x to the 4th, I divided one of those out, so I'm going to start with x cubed. So this is the coefficient 2x cubed, then I have a positive 1x squared, I don't need the 1, and then a positive 10x, and then this is my constant, and then my remainder is 82, and there's two ways you could write this. You could either write this as a remainder of 82, or if it says to put it in fraction form, I put 82 over the divisor, which is here x minus 3. So this would be the answer to this division problem. And I can click on this and we can check the answer down here and you can see we have it right. Okay, make sure you watch the next example. There's something a little weird that happens with that one, and then I'll do a few more examples. You can watch as many as those as you need until you feel you have this process down. But make sure you watch the next one. Okay, in our next example, we have a couple of things going on. We have 5x to the 4th minus 3x plus 1 divided by 4 minus x. Whoops, and take that last answer off of there. Now, the thing about synthetic division, if you go back into what we said here, it has to be in the form, a linear form, and it has to be in the form x minus k. You remember from that factor and remainder theorem that we always had the linear factor in the form x minus k, meaning the x has to be positive. You'll notice in this case, if I were to rewrite this in order, this is negative x plus 4. Now, in order to change this into the form x minus k, I need to change the sign of these, which means I need to take the negative sign out. Okay? And I need to take the negative sign out of the denominator because if I left it in the denominator, I'm still going to have negative x plus 4. So I need to take the negative out of the denominator and move it into the numerator. So I'm going to take it out of the denominator and move it into the numerator. So that's going to change the sign of all of these, which is going to make my expression now negative 5x to the 4th plus 3x minus 1 divided by x minus 4. So whenever you have a situation where your linear factor has a negative sign in front, you can change the expression without changing the value of the expression by taking the negative sign out of the denominator and moving it into the numerator, because you remember in a division problem, if one of the values is negative, or in a fraction, if the fraction is negative, either the numerator is negative or the denominator is negative. It doesn't matter which one, so you can take it out and put it in the numerator without changing the value. So now that I have this set up, I can go ahead and do my synthetic division. So I'm going to use the 0 here, so 4 is going to make that 0, so I'm going to divide by 4. And then I'm going to write my coefficient. So negative 5, now that's x to the 4th. Notice I don't have an x cubed, so I need a placeholder. I don't have an x squared, so I need a placeholder. So then I have an x, and then I have my constant. So 4, 3, 2, 1, constant. I kind of count those down to help me make sure I have that. Then I can go ahead and bring this down and do my division. So 4 times negative 5 is negative 20, and then I add. This is going to be negative 80, and then I add. 4 times negative 80, this is getting pretty large, negative 320. And then I add those, so that's negative 317. And negative 317 times 4, well, let me see if I can't do this. So that's going to be 1200, and then that's going to be 40, and then 7 times 4 is 28. So if I add those together, it's going to be negative 1268. And then I add that, so negative 1269 is going to be my remainder. So now that I have my division and my coefficients, I go ahead and put the variables back in. So again, starting 1 less than what I began with, so this is going to be negative 5x cubed minus 20x squared minus 80x minus 317, and then again I have a remainder of negative 1269, and then I can put that over 4 minus x. Okay, so again, a couple kind of funky things going on there. Remember, this has to be in the form x minus k, so this x must be positive. So the way to handle that is to just take that negative sign out, put it up in the numerator, make all of those opposite signs. Then remember you have your placeholders, and then you can go on from there. I'm going to do again number 3 or 3 or 4 more examples. You can watch as many as you need. Once you think you have it, then you go ahead, stop the video, and tackle your homework. Okay, my next example here I have right here. I'm going to go ahead and start doing these a little bit quicker. So I know what makes that 0 is a -1. I have x cubed, x squared, x, and then my constant. So again, 3, 2, 1 constant. I kind of count those down to make sure I have a placeholder. Bring down the first value, so I have -1, so this is -6. This is +6, makes that 9. This is -9, makes that -11. I started with x cubed, so this is going to be x squared minus 6x plus 9 with a remainder of -11. And then again, if I'm writing in fraction form, it should be like that. Okay, and there's a negative sign right there if you think I missed that one. Okay, another example or two again. You, watch as many as you need, and once you think you have it, you go ahead and tackle your homework. I think I got one up here somewhere. Where is it? There we go. Okay, so this is kind of an interesting one. It's in linear form, so that's okay. So I'm going to divide by -2. Now I need a lot of placeholders here. So I got 8, x to the 8, 7, 6, 5, 4, 3, 2, 1, and then my constant. So 8, 7, 6, 5, 4, 3, 2, 1, and then my constant has a coefficient -1. So multiply and add. Multiply and add. Multiply and add. Multiply and add. I should have left myself a little bit more room there. Multiply and add. Multiply and add. Multiply and add. And multiply and add. So I go ahead and put my variables back in now. Because I was x to the 8th, I go start with x to the 7th. So x to the 7th minus 2x to the 6th plus 4x to the 5th minus 8x to the 4th plus 16x cubed minus 32x squared plus 64x minus 128 with a remainder of a positive 255 over x plus 2. So again, if you need a lot of placeholder, those numbers can get pretty large pretty quickly, but imagine if you had to do that long division wise. All right? And I think that's all the examples I have, so hopefully those were helpful to you. You can rewind this, watch them over again if you need help. But that's synthetic division, and we'll start in the next lesson using this then to find all of the zeros of these polynomials that we're looking at.